Hello and welcome to Computer Tech and More. Today we're going to be taking a look at the Arctic P12 Max. This is part of my redone series where I redid all of the noise testing analysis on every single fan I've tested. First we're going to do a little bit of explanation, then we're going to go over the new versus the old data, and then the detailed explanation of all the graphs in the data. Alright, before we get into the graphs and the data, this is the raw spec information based off the manufacturer's website that I could easily gather for it. So it is pretty much a bog standard 120mm fan with a 25mm thickness. Fluid dynamic bearing, 12 volt, 0.29 amps. So you are getting pretty close to not being able to have two fans on one header with this amperage. Airspeed is 200 to 330, no, not 300, 3,300. Airflow is 81 CFM. Static pressure is right at 4.35. Wow! And noise level at 20.63 decibels. And note that every manufacturer may measure decibels differently, so you can't always directly compare them against each other. And warranty is 6 years. So first, an explanation of what's going on. So previously, I want to make one thing perfectly clear. My old data isn't completely invalid. I just ended up realizing that I wasn't testing what I actually wanted to be testing. So the end result was I was putting my microphone really close to the edge of the tips. So what in effect I was testing or simulating was if you had a mesh filter directly over top of the fan, or you had this fan in a pull configuration over a radiator or AIO heatsink, something like that, that extra noise with the blades interacting with the other surfaces is a lot like how I ended up testing it, which isn't what I wanted to test. What I wanted to test is how this case fan, or how the fan acts in like a computer case, or up against a heatsink in a push configuration, something along those lines. So as a result, I completely revamped my whole testing analysis. So in terms of accuracy, I've also brought up my accuracy. Both the new and the old analysis, I did 3 passes on my tests for like both airspeed and noise analysis, and then I would average the results. But previously, I wasn't paying as close attention to what the room ambient environment was. Now I am. And actually, it's more important now that I've increased the distance from the fan blade, because now I pick up more room noise, which is very important because my room ambient noise is about 30 decibels. So it's a little bit more than 30. So it's a very standard. So my old analysis, I figure, was accurate to within plus or minus 4 decibels, so that's an 8 decibel range. And as you may or may not know, every 10 decibels is a doubling in noise volume. So that's a pretty significant range. The new testing analysis, because I'm looking at the room ambient noise more carefully, I'm getting it so it's closer to plus or minus 2 decibels. So that is a 4 decibel range. So that is an overall great improvement in overall accuracy for the testing. And that's what I'm going to be doing going forward. Unfortunately, this brings me to where I dead end with my current capabilities with this channel. So I would need help from viewers like you, a sponsorship or YouTube, money, whatever, in order to get myself to the next level. I want to upgrade my microphone. Right now I'm just using the one you're hearing me record my voice on. I want to get one that's dedicated for noise testing. I want to upgrade my anemometer. Right now the current one is accurate to within plus or minus 2 decibels. I want to get one that's accurate to within, or not 2, plus or minus 0.1 meter per second. I want to get one that's accurate to within plus or minus a 0.01 meter per second. I want to make a little noise chambers for noise testing to hopefully drop the decibel reading for ambient level to closer to 20 decibels rather than the 30 I'm currently picking up. And it should also help smooth out the noise coming into it, so that I'll be getting much cleaner noise. I want to build a little test system just for doing the kind of testing that I'm currently doing. All in all, I'm looking at like $2,000. You don't need to worry. It's like I'm asking for money, but I'm not asking for money, because if it takes a couple years, it takes a couple years. If it doesn't take a couple years, then woohoo, I get to do the improvements earlier. Until I reach that point, I'll be keep doing what I am doing with the way I'm doing the testing. So if you like what I'm doing, I ask that you join me on Patreon and give your support that way. If you don't like it, well, I guess I'm sorry. Subscribe, that's kind of the best way to support me. Anyways, let's move on to what we're going to be taking a look at. So if you are new to this channel, I do recommend that you watch the second half of this video first, where I go over the graphs and the details and all the specific tests and why they're important, because otherwise you're going to miss a lot of detail and context from this first half of the video. This first half is going to be going over the original testing methodology versus the new testing methodology, where the fans rank, the model that is indicated, the RPM it's running, as well as the test performed. So you're going to see the new ranking versus the old ranking. Alright, so first up is the CPU air cooler test, noise normalized. The P12 Max was originally ranked 23rd. It is now ranked 40th. In 100% PWM fan signaling CPU air cooler test, it was ranked 4th, and it retains that position. For the CPU cooler noise normalized value proposition, it was ranked 6th. It is now ranked 13th. CPU air cooler test 100% PWM fan signaling, it retains this position at 1st place. CFM testing noise normalized, it was ranked 18th. It is now ranked 40th. CFM testing 100% PWM fan signaling, it retains its position at 2nd. CFM testing noise normalized value proposition, it was ranked 5th. It is now ranked 11th. Value proposition CPU or CFM test 100% PWM fan signaling, it retains its position of 1st place. Case simulation test 6-inch mark noise normalized, it retains it, or it was ranked 24th. It is now ranked 38th. Case simulation test 11-inch mark noise normalized, it was ranked 16th. It is now ranked 25th. 6-inch mark value proposition, it was ranked 8th. It is now ranked 11th. 11-inch mark value proposition, it was ranked 3rd. It is now ranked 7th. So this brings up a general concern that some have expressed over Arctic fans, where they're not as consistent in their manufacturing processes. So it very well could be that my second sample of the P12 Max that was used in the new methodology was a lemon compared to the original one. So I do hope to acquire another sample in the near future to do a second set of testing on it to see, well, consistency's sake. So I hope you're looking forward to that. It'll be a real short video where I just be like, hey, updated. Alright, let's go into the updated graphs and the details. First up is the case simulation test. This can be looked at in a couple key different ways, but first and foremost, the most important for you, the viewer, is what size case do you actually plan on buying? And by that, I mean literally, what size case do you plan on buying? So I took key data measurement points at the 6, the 9, the 11, and the 14.5-inch marks. Now this distance isn't the length of the case. This is the length from where the CPU fan, or where the front case fans are, to the approximate location of your CPU socket. And this is for specifically, or most important, for air coolers. So assuming an air-cooled system. So first and foremost, the 6-inch mark is for small form factor cases, so ITX motherboards. But this is still assuming a front-to-back airflow type design, not the ultra-compact ones like the Fractal Design Terra, which suck in air from the sides, blow it out the top, or other ones of similar design. I want to make sure that's perfectly clear, because those ultra-compact ones are actually better. You want fans that are more closely related to, you want to use the data set for CPU air coolers, because those cases you actually need good static pressure fans, because everything is so tightly integrated that you actually need the static pressure to blow the air around all the components. The 6-inch mark is also representative of short throw distances. So if you're going to be using your fans at the bottom of your case to blow up into your GPU for that kind of cooling scenario, then the 6-inch mark is very representative. The 9-inch mark is representative of a compact tower. Think something that can hold an ATX or MATX motherboard, and the GPU is basically the length of the motherboard. And then you got the fans in the front. That would be that size case. What I think of are like the Dell Optiplexes, they're business computers. Then we have the 11-inch mark. The 11-inch mark is representative of your compact tower, something like the Corsair 550D, Meshify 2C, something like that. And then you've got your truly large cases, something like the Fractal Design Torrent, and that's represented by the 14.5-inch mark. So again, depending on what size case you're actually going to use for your air-cooled system, you want to look at each specific data point. So if you haven't decided, I would actually pick and choose. I would go with the bigger case as opposed to the smaller case, because it's harder to find good fans that can blow that long distance. And the reason this is important is Well, let's go into how fans work. Well, fans accelerate air, so they have to pull a small vacuum on the front of them. So if you have a small vacuum, so that means the fan is pulling air and then pushing it. So if you have a high quality fan on the front of your case that is supplying air to this CPU fan, then this vacuum is sort of non-existent. It allows the CPU fan to run much more efficiently and effectively, thus improving overall thermals inside your case and through your CPU socket. If you're using an AIO or a radiator system where you're just air cooling your CPU and you don't have any bottom case fans, you still want to make sure you have got good high quality fans blowing through your radiator or AIO to make sure that enough airflow is being supplied to your GPU to prevent it from overheating. And if everything is hooked up to a radiator, then it doesn't matter as much how the quality of the airflow going through your case. You just want to make sure that the air can exhaust out, because you've basically reduced the thermals within the case, like the heat generating components are kind of extracted away from everything. So then you just need to worry about like motherboard temperatures as opposed to the CPU temperatures. I mean, you still need to worry about CPU temperatures, but they're probably not going to be an issue with that kind of system. So that brings me to the point of what type of fan to actually get. So in my opinion, you always want to get a good concentrated airflow design, no matter how you're going to be using the fans. If you're going to be using them on a heatsink, radiator, AIO, it just doesn't matter. You want to always have high quality airflow, because then if a fan dies somewhere else in the case, you can reuse that fan elsewhere. While if you get one that's good at static pressure and it blows air off to the sides in this wide flow pattern, it's only good at a unitasker. It's only good at one type of task. So if you're going to be using these fans in a pull configuration on a radiator, heatsink, whatever, the airflow pattern coming out the side of it will look like the airflow pattern that is in my test analysis. But if you're using it on a CPU air-cooled system, so in an exhaust configuration, it doesn't really matter as much in that position, simply because you're already so close to the back of the case that your exhaust fan should be pulling it out no matter what sort of airflow pattern it is. But a fan at the front of your case, then it really does matter. I just want to give that explanation in there. So what kind of flow patterns are we actually anticipating? Like the most idealized fan in the world, so like mathematically idealized, would be a perfectly flat line. It would lose no airspeed from the front of the case to the back of the case. Unfortunately, there are air losses inside the case, so you'd actually expect it to have some loss. So what you're looking for is the loss to be as gradual as possible and as linear as possible. What you don't want to see is a steep drop off to zero, because that indicates a very poorly designed fan. Now that brings us to a general comparison point. So I have a control fan. This is 3 parts A12X25 to 1 part A14. 2 good fans in the respective categories. In general, I find that 140mm class fans do better at the 11 and 14.5 inch mark, while smaller 120mm class fans tend to do better at the 6 and 9 inch mark. So my composite fan there, which I'm labeling as control, is there to be a good representative mark of what we'd call a good fan versus a poor fan, just as a general place marker. So with that place marker in mind, we can see that the regular P12 closely matches my control fan. So that indicates actually that the P12 is a pretty darn good fan. While the P12 Max and the Iceberg Thermal, I chose that fan because it's also a 3000 RPM fan, are well off the beaten path of my control fan. Again, I do believe that the P12 Max is actually just because of a consistency sake, where I got a little bit more of a lemon for my Max in the second sample off of Amazon than the original one in my previous testing. How about at 100% PWM fan signaling? This allows the fans to go balls to the walls, full speed ahead, and we do see that the P12 Max is doing really well. But amazingly, that the slower RPM Iceberg Thermal Ice Scale Extra is outperforming it at the 6 and the 9 inch mark, and they tie at the 11. So this is sort of an example of how different blade designs can have different effects on your performance. And you can see that by the 14.5 inch mark, many of the fans are actually very closely grouped together. Then we have, how does this fan compare to other fans I have tested? So right here, this yellow line is the Wonder Snail. I consider this fan the bottom end of what I call the good fans. And the reason for that is purely because of the 14.5-inch mark. It is just a very efficient design where it doesn't lose much airspeed from the front of the case to the back of the case. So I consider it the bottom end of a good fan. We see that the P12 Max is towards the bottom. Unfortunately, I put it as a relatively low performing fan as a case fan. At least this sample. So again, I do want to acquire another one to see if I can get better results, and I'll probably have to average them because realistically, I can't expect all of you to always get the perfect golden sample, so I need to be realistic with the way I'm analyzing this fan. At 100% PWM fan signaling, it is doing a banger job. It is definitely well towards the top of the graphs, so it is it is doing excellent there. But here's the problem. You're not going to be running your case fans at 100% PWM fan signaling. If your case fans are running that fast, something is probably terribly overheated inside your case. So you may need to rethink like your thermal paste solution or something like that. Excuse me. Got a little bit of cold. Next, we're going to be taking a look at the 9-inch mark airspeed versus decibel. And the 9-inch mark was chosen because a lot of fans that tend to lose airspeed quickly drop between the 6 and the 9-inch mark, so I needed a data point that was over 0.5 meters per second, where my anemometer becomes a lot less consistent. So the 9-inch mark was chosen because the majority of fans tended to have higher airspeeds at the 9-inch mark, while still showing a good separation between the fans that had a concentrated airflow design and ones that tended to spew air off to the sides. So we do see that the P12 Max starts off kind of middle bottom performer, but it quickly climbs to be a top performer. So this indicates that depending on what sort of RPM and usability of you want out of this fan, it could be a great performer or a very poor performer. Next, we're going to be taking a look at airspeed through my CPU air cooler, the Noctua U12A. In these graphs, better fans are going to be sitting in the top left, worse fans are going to be sitting in the bottom right. And the first one here on the left side is RPM versus airspeed. Airspeed is vertical, RPM is horizontal. And basically, this fundamentally is a blade efficiency graph. It is how good is this blade design at shoving air through my cooler. So we have the P12 in here, we have the P12 Max, and it's good that the P12 and P12 Max line up very closely, as they do share a very similar but not identical blade design. And then we have the ice scale iceberg thermal extra just as another indicating point. So the P12s are lining up fairly closely with my control fan, which is great to see overall. Next, we're taking a look at noise versus airspeed. This is the right graph. Airspeed is vertical, noise is horizontal, and we see that the P12 Max is noisier than the P12. Actually, pretty significantly noisy, but it is also climbing in a very efficient manner. The ice scale extra is also climbing in a very similar way, indicating that both of them at higher RPMs are fairly noise efficient for how much air they push, but you basically have to get there. So you have to be willing to accept that extra noise in order to achieve that extra performance. So then how does it compare with other fans? First, a little bit of explanation about what's going on over here. We have a 225 W, that's 225 watts, equals 2 meters per second. So this is an airspeed. I did a whole series of tests on my cooler for what wattage equated to what airspeed by letting the CPU hit thermal max with one fan on it, measuring the airspeed going through it, and letting the wattage stabilize. Then I decreased the PWM fan signal, let the wattage stabilize again, measure the airspeed, and I was able to create a number of a graph for wattage versus airspeed. Now this is true for my CPU, which is the i7-11700K, and for my cooler, which is the Noctua U12A. So if you don't have either of those, how can you use this data? Well, you can use it as a comparison point. So let's say you have the Storm T3 hooked up to your CPU cooler. It is blowing air at 0.8 meters per second. Well, if you upgrade to a T30, you're now going to be pushing air at 1.3 meters per second. At least on my cooler. So your airspeeds will vary, so your wattage improvements will vary, but the trend should hold true. So that means that if you get one of these top-end fans and you're from one of these bottom-end fans, your CPU will be able to run at a higher wattage for the same noise level, or if your CPU is locked, your CPU will run cooler for that same wattage, original wattage, or you can back off the PWM fan signal, so now your system will run quieter for the same wattage. It is your choice how you use it. Now, the P12 Max is kind of at the bottom of the graphs. So again, I want to get another sample to see if I ended up getting a lemon, and I will have to average the results or just have it listed 2 times. But at 100% PWM fan signaling, we see that the P12 Max is right at the top of the graphs. It is doing really, really quite well. It is in 1, 2, 3, 4th place. It is also spinning significantly faster than the other fans in its category, while being quieter. So that is overall a fantastic result. For how fast it's spinning and how little noise it's producing, that's a banger. And you can see on here the A12X25 is right here, well away from it. It is pushing a lot less air, but it's also more, approximately 10 decibels quieter, so it's almost half as loud. So you do have to pick and choose what is most important to you. Do you want extreme performance, or do you want to make sure that your system isn't too noisy? I can't make that decision for you. I can only present the data. And with regard to that, here is the P12 Max, and we do see that it starts off as a relatively poor performing fan, but it quickly climbs to being a top performing fan. But you do have to accept the higher noise level, even though it's actually outperforming the other fans in that same sort of high RPM category. It is still noisy. It's less noisy, but it's still noisy, and it's something you have to accept about this fan if you're going to pick it. You have to accept that it's less performant at lower RPMs, but that it's going to be a very top-end performer at higher RPMs, but it's going to be noisy. I can't make that decision for you. Arctic P12 cold configuration.
Arctic P12 Max. Arctic P12 Max.
Next, we have CFM testing. CFM testing, as most other reviewers use it, I don't particularly like, and allow me to explain. First, generically how CFM is calculated. CFM is a volumetric flow rate. You have a fan, it blows down a tube. The fan is the same size as the tube. My tube is circular. So to get the surface area of the tube, it is pi r squared. So let's put r in feet. You need the airspeed. You measure the airspeed with your anemometer. Let's put it in feet per minute. So that's feet per minute times feet squared. So that becomes feet cubed per minute, or cubic feet per minute. We now have a volumetric flow rate. You don't necessarily need to use volumetric flow rate, but it is a good indicator of performance, and it makes the numbers look a lot bigger. But the reason I don't like it is, as most other reviewers use it for testing how a fan is in case tests, is the fan is the same size as the tube. So if you have a fan that has a tendency to blow air off to the sides, there's no room for that air to expand. So thus, all the air is going to travel down the tube. Now, this is a case where you could end up with getting the right result for all the wrong reasons. Basically, it's like every single step in the math was wrong, but you ended up at the right answer. So the professor would still give you a 0 on the test. And where was I going with this? Oh, so it has a tendency to, so there will be a tendency for the fans that blow air off to the sides, even though it's all traveling down the tube, they will still blow it at a lower speed on average compared to one that has a nice concentrated airflow. But the difference between the two fans, so the concentrated airflow versus the non-concentrated, are going to look a lot closer in performance than they do on the case simulation test, which is why I think the case simulation test is actually golden. It's actually much more important than this test, because it gives you the indication of how good this fan is in actual case airflow, while this one is sort of like halfway in between doing a CPU cooler and a case test. Now, this sort of test is completely valid depending on how you want to use it. So if you want to use it for scientific purposes, basically generate some PQ curves for how good the fan is at different pressure scenarios, perfectly valid, like how Noctua tests their fan. It makes a lot of sense, because then it tells you how good this fan is in different types of pressure scenarios. No pressure and max pressure. but you do need to include that open case environment test to see how efficient the fan is at actually blowing air. That is at least my opinion on the matter. And so reviewers that don't understand that really shouldn't be completely trusted. At this time, I would like to indicate my background. I am an aerospace engineer. I have a background in computational fluid dynamics. It was my specialty in my master's degree. So this is a topic that I know a bit about. Even though I've never worked in the fan blade industry, I still understand the fundamentals of what is actually going on with these types of things. So I guess I'd like to be a trusted source on this sort of topic. Now, this brings me to the CFM tests where I blew air down the tube, and we can clearly see that all the lines, dotted lines, pretty much almost exactly line up. So it's like case and point. They're even more closely packed, like lined up, than they were when I took measurements through the CPU AirCooler. So it's like even more of a case and point. So it's not really that interesting. Noise results, very similar to what we saw before. The P12 is a little bit noisier than my control fan. The P12 Max is noisier. The Iceberg Grail Extra is noisier. Let's just move on. So how does the P12 Max rank? Well, it is towards the bottom of the graphs in noise normalized results. And at 100%, it's at the top of the graphs. It isn't the best, but it's right up there at the top. So how does its line look? Well, it starts off pretty bad, and then it quickly climbs to the top. So, I mean, it's a trend we've already seen, so it makes a lot of sense. So this brings us to value proposition. The P12 Max is a $12 fan. These are all based off standard retail pricing as I could find it. So note that depending on what region you're in, availability, sales, the value proposition does change. So it is based off standard retail pricing. Now, value proposition is most important for those of you who are on an ultra tight budget, where you're trying to squeeze every penny out of your build and get the best bang for your buck. But key things that value proposition is missing. It's missing absolute performance, and it's also missing reliability. I hope to add reliability testing in the future at some point, but it's another thing that is on the back burner until, well, I'm a big enough channel that, well, not necessarily making money, but at least I'm not losing money. So I'll just have to leave it at that for the time being. So where does this leave us with the P12 Max? Well, in noise normalized results, it's actually pretty good at the 6-inch mark. It's not the best, it's far cry from it, but it's not bad. At 100%, again, you shouldn't be running your case fans at 100%, but there it's doing really quite well at the 6-inch mark. How about the 11-inch mark? Well, once again, the P12 Max has shown itself to be fairly good. Mind, the regular P12 is a much, much better value, but at 100%, it's really good. But again, you shouldn't be running your case fans at that speed. How about through the CPU cooler? Well, it's well above average. Again, in absolute terms, there are many fans that are a much better value, but running it at 100% PWM fan signaling, it's doing pretty okay. So I'm going to just give this explanation right here. If you're okay with its minimum noise level of the P12 Max, it would be a great choice to just slap onto your CPU cooler or radiator or whatever you want to use it as, because it's already providing you a very substantial amount of airflow so that it may not ever need to ramp up, but it has that extra overhead in case you need it. That is just kind of my general thoughts on it. So first you need to be able to put up with its minimum noise level, and then you also need to be able to put up with its maximum. So I personally would only use it on a CPU cooler, and I'd ignore it as a case fan. But anyways, CFM testing, again, it's above average, 100%. It's the top performer here. But realistically, in all these graphs, the TLG12 is, in absolute terms, the best value. And the P12 is also a truly excellent value. It always ranks very highly. So my thought with the P12 Max is I would use it on a CPU cooler, but not anything else. And you need to be able to put up with its noise level at minimum RPMs, because it's already relatively noisy at that level. Its minimum noise level is about the same level as the A12X25 at my baseline noise normalized results. It's actually a little bit noisier than that. So you need to be able to accept it. Let's move on to the next step. And that brings us to the end of the video. At the end of every video, I do like to show off my raw data. This data does belong to me. I am the owner of it. And you are welcome to use it for your own personal use. By that I mean is you input it into your own Excel table and you can manipulate it however you want as long as it's only for you. If you're going to use it in any sort of written, journal, publication, video, whatever, I do ask that you reference me and my channel and that you ask my permission before doing so. Mostly because it's just polite, even though it is on YouTube and probably is considered public space. I am the owner of the data. If you got suggestions for me on how to improve my videos, I am welcome to constructive criticism. Just note that it may take a little while for it to be implemented into videos, as I tend to do large groupings of buying fans and then recording them. So there may be a time delay between when I can implement your suggestions. And speaking of suggestions, if you got suggestions for fans for me to take a look at for future testing, please leave them in the comment sections down below. Amazon is the easiest way for me to acquire fans currently. So I ask that they're just available on Amazon in case it's something I've missed. I've got a lot of fan videos on my channel already, and there's going to be this whole grouping of like 70 fans coming up. What else? Subscribe, check out my Patreon page. It really will go a long way to furthering this channel and what I'd like to do with it. And other than that, have a great day. Hope to see you next time here on Computer Tech and